In this video, we are going to cover finding the potential function, exactness and evaluation of the integral. So finding the potential function, show that the vector field f is equal to, this part is equal to p, and this is equal to q, and this is equal to r, is conservative over its natural domain, and find a potential function f such that vector f is equal to gradient of scalar f. Step 1, check for conservativeness. So a vector field f is conservative if del q by del x is equal to del p by del y, del r by del y is equal to del q by del z, and del p by del z is equal to del r by del x. This condition you can obtain by putting curl f is equal to 0, I, j, k you can write in the first row, del by del x in the second row, del by del y, and del by del z, and in the third row you can write p, q, r, and solving and putting it equal to 0, you will get these conditions. So we'll check these conditions. Here you can see these two are equal. Again, these two are also equal, and these two are also equal. So since all three conditions hold, f is conservative. Now we'll find the potential function f. Since gradient of f is equal to vector f, therefore del f by del x is equal to p, del f by del y is equal to q, this is the value of q, del f by del z is equal to r, the value of r. Now we integrate f partially with respect to x. So integrating will get the value of f x comma y comma z, that is equal to e to power x cos y plus xyz plus gy comma z. Since gy comma z is a function of y and z, we determined it using the second equation. So second equation, del f by del y fxy is equal to e to the power x sin y plus xz plus gy del y. So we'll put the value of del f by del y at left hand side. We'll get this equation. So del g by del y is equal to 0, means gy comma z is equal to only the function of z. Now we'll put the value of gyz in the equation number 5, and then we'll find the partial derivative of that equation with respect to z. So del f by del z is equal to xy plus z and del h by dz. So del f by del z is equal to xy plus z. We have already found this value. That's why putting this at left hand side, we'll get del h by dz is equal to dh by dz is equal to z. Integrating this, we'll get the value of hz is equal to z square by 2 plus c. So we'll put this value in the this equation number 5. So f of x comma y comma z e to our x cos y plus xyz plus z square by 2 plus c. Next topic is exactness and evaluation of integral. So show that y dx plus x dy plus 4 dz is exact and evaluate this integral. So given that y dx plus x dy plus 4 dz is equal to m dx plus n dy plus p dz. Comparing, we have m is equal to y, n is equal to x, and p is equal to z. So applying the test for exactness, complete partial derivative, the same condition which we have seen in the last example. Here in the place of pqr, it is m, n, and p. So first condition is this: del n by del x is equal to del m by del y, del n by del z is equal to del p by del y, and del m by del z is equal to del p by del x. So evaluating this, you can see these two are equal. Similarly, these two are also equal and these two are also equal. So conclusion, since all conditions are satisfied, y dx plus x dy plus 4 dz is equal to df. We solve for some function f by integrating the following equation: del f by del x is equal to y, del f by del y is equal to x, and del f by del z is equal to 4. So from the first equation, we get f is equal to xy plus gyz. The second equation tell us when we partial find the partial derivative of f with respect to y, del f by del y is equal to x plus gy, del g by del y is equal to x, so that del g by del y is equal to 0. So gy comma z is independent of y and it is only the function of z. So we'll put the value of gyz here and we'll write f is equal to xy plus hz. So g of yz is a function of only z. That's why hz is written here in the place of g yz. So the third equation tells us del f by del z is equal to 0 plus del h by dh by dz is equal to 4. Integrating this, we will get hz is equal to 4z plus c. So thus we obtain, putting this value in place of hz, will get f of x comma y comma z is equal to xy plus 4z plus c. Now to compute the integration, we'll put these points in f, final point minus initial point. So computing this point in the f, will get this value 2 plus c, and now we'll compute f at 1 1 1, so we'll get 5 plus c. So this is a conservative field, therefore integration will depend on final point and minus initial point. So 2 plus c minus 5 plus c is equal to minus 3. This is the final answer. Thank you. PDF of the lecture is given in the description box.